Hello everyone, my name is Frank Fan. I'm Container Specialist Solution Architect. Welcome to our session today about architecture decision making. We use Kubernetes environment as example, but the process and the practical tips applies to all the technical domains. I'm very thrilled to introduce my co-presenter, Fasel. Both of us are deeply passionate about this architecture thinking and have dedicated our careers to these fields. Together, we have navigated many real-world challenges and developed practical processes to help professionals like you make informed architectural decisions. We look forward to sharing our insights and experiences with you today. In the session today, we'll cover challenges people experienced and how to leverage working backwards framework to help with decision making. We will also demonstrate the processes with real-world use cases and show you how to generate architecture decision records on your own. Choices. There are so many options. You need to make a lot of decisions to make Kubernetes platform production ready. The ecosystem around Kubernetes has rapidly expanded with numerous third-party tools and platforms integrating seamlessly with this technology. Fast pace of technology evolution. Generally, there was a new Kubernetes release roughly every 3 months. Each release introduces new features, improvements, and bug fixes. The team skills changing as well. It's rapidly evolving because your collective efforts in staying updated and attending conferences like today. The abundance of options, rapid innovation can lead to self-doubt about your decisions or slow your decision-making process. As your skill improve, you need to start designing things in more flexible and adaptable way. This code deeply resonates to our role. You are earning trust by helping people make high-quality decisions at right time. Don't ask me which famous person said it before. Well, I made it up myself. However, this is a true quote from Herbert Simon, a Nobel Prize winner and a pioneering scholar in AI and decision making. This quote essentially says that even the smartest people, despite their best efforts, often face challenges because the human mind has its limitations when dealing with vast and complex problems. Working backwards is Amazon's process of discovery and invention that delivers customer delight. It can also be used for architecture decision making. There are 5 stages here. Stage 1, listen. So what insights do we have about the customer and their motivations? We could gain insight from our colleagues working with the customer before and validate our understanding during the meeting. The key is to understand the motivations for a customer willing to make a change. And what are the priorities? For example, is this driven mainly by cost saving or improving developer productivity? Define. There are many areas you can work on, but it's essential to understand the context and clearly define the scope of the area where it has a big impact and you can add value. Invent. What solution would you propose to solve the problem just defined? Why is the right solution versus other alternatives? Refine. Now you propose a solution for one area. What are the implications of this decision to other areas? For example, how your operating environment will have implication of security boundary. How will the new technology recommended fit into the existing technical landscape? Any migration paths and effort people should consider? What's end-to-end experience look like for all the relevant technical stakeholders, including the consumer of your customer's product or platform? Test and iterate. How would you validate the proposed solution work as expected? What's a process? What's a success criteria if you do a POC? What test use cases you should consider? Let's dive into the listen stage. We leverage this technical radar framework. It helps organizations visualize and manage adoption of new technologies. It helps us understand the current technical landscape of the client environment. There are 4 areas. So each stage have a different meaning. For example, the life cycle of the adoption could start from assess, POC for trial, and decide to adopt. But when you revisit that, maybe you need to put that on hold if something changes. So at a later stage, we'll refer to this technical radar to determine which stage the new solution fits into and understand its implications for the other technologies on the radar. At define stage, we write down the context and the problem statement. So think about what technical requirements in this example. Which ones are functional requirements? Which ones are non-functional requirements? Yeah, you're right. So onboarding is functional requirement, but at the same time need to also meet the non-functional requirement to help you can onboard when you scale at a large scale, but at the same time, the operating team have a consistent way to deliver this workload. So all these things we need to write down to help us to review. So next stage is about invent. So this stage we consider options and make recommendation. Here are 2 options, and the customer decided to choose option 1. Can you think about why? Yes, because the non-functional requirement here, consistency has high priority. Yeah. And maybe another thing we didn't mention, but constraint. Maybe the tenant team doesn't have skills to provision and manage clusters themselves. So all the reasons is very important to write it down for future review. Beyond that, we also need to go to the refine phase. So here, we need to assess the consequences, right, about this decision. You meet the requirement about consistency, but at the same time sacrifice or compromise on developer flexibility. The impact for that could slow down the business to release new features. And also we need to assess other decision making will get impacted by this one. So here's a diagram to illustrate this decision. You can see the 3 teams, the infrastructure team, content, platform team, tenant team, they have their own responsibilities. So content, container, platform team look after Kubernetes platform provisioning and management on behalf of tenant team. Tenant team just focus on application deployment on top of that platform. So we just walk you through the process, right? Listen, define, refine, and then you figure out a way to how you validate this operating model works for you, start a POC and test it out. Are we done? Not yet. This is an ongoing process, and they need to be iterated when situation changes. So for example, this organization just acquired another company, and the team is very skilled to provision and manage Kubernetes clusters. So this will trigger an action to reassess the decision made in the past. So previously, consistency is high priority, right? There's a constraint about a team's skill. The version 2 of the statement has been changed. Flexibility is super important for the newly acquired team, and they are very skilled. And then there's a good reason to transform from previous model to a hybrid model. So other teams lacking of skills can continue leveraging the existing model, but for the new team just acquired, we can call it platform-enabled model. Here, in this model, the container platform team no longer provision and manage clusters for this specific tenant. Instead, they build a platform and provide blueprints that a tenant can use to provision and manage their own clusters. Every architect decision is interconnected and impacts others. For example, if the platform team adopts an operating model to provide a shared environment for tenants, they must structure their account strategy to enable tenants to easily leverage the shared platform with their own data sources. Additionally, the account strategy will influence the security boundaries between tenant environments. Now I hand over to my colleague.
Thank you, Frank, for explaining us what ADR is, what problems they are solving, and how they are bringing consistency into your architecture decision. My name is Faisal Masood. I am a senior SA in the ISV ANZ business vertical, and I'll be taking further the discussion of ADRs and how they could look like in the real world scenarios. So before we go in deep into some of the decisions, let's revise what Frank has mentioned earlier, how an ADR could look like. So title of the ADR, the status, because ADR could be updated, it could be proposed, rejected. So status is very important field for ADR. Then we add a field called context. So context is explaining to the reader, to the audience, what scenario is making me this decision, like why this decision has to be taken under what circumstances, and that what context will cover. The decision itself, a very important thing is to add other options that has been considered, because architecture is all about options. You see a famous saying of architecture, for every answer, the answer could be it depends. So we weigh the pros and cons, and we consider other options to achieve the same requirement. So the reader has a fuller understanding of what has been gone through in this ADR. Then the consequences, how this decision will affect the way people work, the operating procedures, and the compliance. The compliance actually cover, once the decision has been made, what processes, what guardrails are in place to make sure that the decision has been implemented, being implemented correctly. So it's not about enforcing, it's about making sure that we are not making mistakes during the process, and the decision has been implemented in the right manner. Other than that, there are some metadata fields like ID of the ADR and related ADR fields, like what other ADRs it depends to, and you will see in the remaining section of this presentation. So now you can see ADR can cover at the enterprise level some decision, or a cluster level in case of Kubernetes, but it can cover application level or a part of application. So it can be possible that you may have dozens or even hundreds of ADRs in the enterprise organization. So an ADR has a life cycle, so it has, you can update them, it can be rejected, superseded. So you need somewhere where you can keep the audit, the versioning, and the RBAC capabilities, and Git is the right place to do. So my recommendation would be store the ADR in Git. They are documents, and from there you can have a full auditing capabilities. You can see who has accessed that, you can see full version history, and you can manage the status of the ADR. Of course, do not email them. And when you are talking about multiple teams bringing the ADRs, um, making sure that ADR has a defined architecture, has a defined structure around it, a standardized structure around it, because um, otherwise it will be difficult for people to read and understand the meaning of the field. So the example that I gave you, what fields ADR could have. So it's important that we bring on standardization in the format of the ADR. And there are a lot of tools available. You can see one of our GitHub repo where we have some of the example decisions. So make sure we bring on standardization across teams, across business units, so that ADR is following a standard um, structure within your organization. So let's try to build an ADR first. So when you're talking about Kubernetes, a lot of time Kubernetes has been is going to host multiple application for multiple teams. They may be trusted workloads, but the infrastructure would be shared across multiple teams. So this ADR will cover how we can bring on multi-tenancy via namespace and network policies for application services. So how we make sure that multiple tenant actually, when they're sharing the infrastructure, how they can create boundaries for them so they can work in their own little isolation. So we have an ID field which I forgot to add in the previous slide, and the status is proposed. Then we have context. So the context, as I mentioned before, is we are going to run multiple trusted workloads. That's very important here, is the workloads are trusted so that they can work on a shared infrastructure, because containers will be run on the same host, for example. So that's one. And the other one is, when we are sharing the resources, we want to put some sort of guardrails, some sort of controls, so that right resource has been available to right hardware has been available to right service or computing system, and they have some network boundaries. So this is the requirement we have. This is the context we have. This is why we are making this decision, because it's a shared infrastructure. We want to trusted workload, and we make sure everybody gets their fair share. So the decision would be, you can see here the decision may cover multiple statements here. You can see here, first is we're going to create namespace to individually manage components. So we are not saying teams here, for example, or not saying environments like dev, test, QA. We are saying every component will have its own namespaces with restrictive RBAC, and we'll apply the deny all network policies via policy engine. So you can see it's a very full kind of sentence. It's covering multiple things. It's covering RBAC, it's covering network policies, it's covering namespaces per component. Then the second part is we actually want to manage the hardware allocated to particular components. So we say, okay, we'll use via quotas and limits within namespace boundaries. Now I personally like to put examples so that reader can understand and implementers can know what kind of have some clarity for implementers. So you can see here, even if you have a SaaS application, it may have multiple components like front end, or customer management, or product recommendations, and every component will have its own namespaces as per this ADR. And then giving some of the justification that with the combining namespace with the network policies, we'll have basic network boundaries for isolation at the SDN level. So that's the decision we are taking. Now you can see here, we are taking the decision and providing some little bit of operational guidance on how it will be implemented, but we are not talking about a lot of technology, because that can be a bit more detailed. Of course, consider other options that we have considered. So first thing we have considered is how about if we run one service per cluster. So the benefit of that will have stronger isolation, but it will cost more and add more management overhead. So we dropped that idea, and we adopted the namespaces one, which is the decision. So in the considered options, you can see here we have discussed the other options that we have considered and a little bit of pros and cons of each option. The consequence of the decision is when we are, because we have more teams and more projects are coming, so there can be many namespaces will exist, and managing them could be a challenge. So we are recommending a change in operating procedure to use via GitOps principles. So if you are already using GitOps, that's good. If you're not using, we are recommending to adopt GitOps so that we don't have that management or complications that can come with manually doing things. Then we have team will have RBAC policy, RBAC to deploy pods, so that we have limited access to the teams and read-only access to the Kubernetes API application. So how we make sure that it's compliant? So we will use the namespace creation is controlled by GitOps as we mentioned, and for network policies, it will automatically create deny all network policies. And if you want to add some incoming or outgoing traffic, you need to create a PR which security will approve, and that will automatically get applied. So we have the compliance making sure that everything is controlled by operations and security people involved in the GitOps process, and some of the related ADRs. So that's an ADR. I hope you get an understanding of what it could look like. So in the spirit of understanding a bit more, so you can see here when we talk about soft isolation, there are isolation at multiple levels. So the number one isolation is the control plane level. So control plane is you have a cluster API, for example, API server, for example, and now control plane is shared in EKS, for example. So multiple service owners will have limited access to the control plane, and we control via RBAC. So that's a number one level of isolation. Then we'll apply limits and quotas for hardware distribution at the namespace level. So that's the second level of isolation. The third level of isolation, we apply network boundaries via network policies. So it's all deny all. If you want to add something, it needs a security approval. So that's a third level of isolation. And the fourth and final level of isolation is we'll have service account to not only within the Kubernetes cluster, but the components that you are requesting outside the cluster, such as RDS databases or KDS or MSK. So we'll use a capability called IRSA, IAM roles for service accounts. I know there's an EKS pod identity, which is a hotter topic, but we are talking in the ADR is how we're going to manage that. So we cover all level of isolations within the cluster, within the control plane, within the data plane, and external services. So that's complete the first ADR. So we provide isolation at multiple levels, and we capture this in an ADR, and we expose them how we're going to implement and how we put controls around that. So that's the number one ADR. So let's look into the another ADR. Let's talk about the secrets management. So the title is we want to make sure that where we store our sensitive data for our SaaS applications. Now here I can put, if you can see, I have put a SaaS application here. So it can be applied to all the application in the cluster. But remember in the beginning of my session, I mentioned that the ADR can apply to an application or the cluster or a part of application. So there I want to give you that example, that flavor, that the sensitive data is this ADR is related to one SaaS application only, for example. Of course, we have an ID and the status. And the context is basically we want to load sensitive data into the application, let's say passwords, private keys, without making any change in the application itself. Now, of course, the application can read from HashiCorp vaults, AWS Secrets Manager, something like that, but we don't want to change the application. That's one of the context. And we also don't want to store the sensitive data as Kubernetes objects such as secrets. So that's the two requirements, and we want to make sure that we make a decision that actually cover those requirements. So in the centralized secrets management ADR, we say, okay, the decision is to use third-party secret provider, so the confidential data is secure outside of your cluster, because one of the requirement was we don't want to store sensitive data in the cluster. But how do we load that data without changing the application code? Of course, Kubernetes has a CSI driver. So we'll use a CSI driver that can load the sensitive data on demand. And in our case, we'll use AWS Secrets Manager as an external secrets provider. So you can see here in the decision we talked about what are we doing and some of the reason what we are doing around that. Now consider the option we use, of course, Kubernetes secrets. Everybody knows secrets are not secrets. We can even use sealed secrets, but sealed secrets will ultimately get unsealed and deployed as a secret. So that actually may not cover all the requirements that we have. So we actually cannot use sealed secret in a particular situation. We can of course change the application, but the requirement was to minimize change or no changes in the application itself. So otherwise it will be a large effort to make changes in our application stack. So we cannot use that. So the third one is use the external secret store. So we talked about other two options that we discussed and the reason why it could not be a fit in this particular case. Of course, the consequences is good consequences and bad both. The good is no application change required. We'll apply existing GitOps principle because CSI has a CRD, so we can use CR and CRD objects to use the existing GitOps principle to load a particular secret in the pod. There is a bad part of it also, right? And that's like if you're storing sensitive data outside of the cluster, and let's say the secrets manager services has some effect and we want to scale our application, then it may hurt the availability of the application if the secret store is not optional. So because we're adding one more component into our solution, so of course the resiliency of the overall cluster will depend on that excellent solution. So that could be a thing that we need to consider before doing that. The compliance is easy, so we'll use a secret provider class which is CRD object, so that and then we'll apply GitOps principle. So somebody will request a secret provider class, security will approve it, and we have the full audit in our back around that. Let's see in a little bit more detail how this look like. So you can see when you install the CSI driver, install a CRD first. On the top you can see the CRD. Then at the runtime, what happens when somebody requests a pod by deployment, direct or whatever way you request a pod, the kubelet will go to CSI driver and say, hey man, this pod require a volume as per, and is loaded from this external store. The CSI driver say okay. The CSI driver then go to the secret provider. In this case, it's AWS secret provider. That will go to the external store, such as AWS Secrets Manager. It will decrypt and provide the information to CSI driver. The CSI driver will mount this as a volume. So it doesn't create a Kubernetes object. It will mount that information as a volume onto the pod, and the application will read it from the local file system. So that's the way we are. The CSI driver will help us load secret at the runtime without creating any etcd objects like secrets. So let's see how the CR looks like. So you can see here is a secret provider class is an object that is required by CSI driver. You can see the provider is AWS, and we provide the name of our secrets manager object like DB credentials, right? And then we'll say the object type is secrets manager. So the development team will request this CRD via GitOps. Security will see it and approve it, make sure we have the right access control. And then in the pod definition itself, you can see here we have a volume. So we have a CSI volume, and the CSI volume, we can just say that the CSI will come from secret provider class, which is a tech demo, the name of the secret provider class you can see on the left hand side of the screen. And then it will be mounted. So it will mount it as JSON, and from the application can read all the username and password of the application. So this is the second ADR, which is explaining how the CSI driver will be used to load it. So some of we have Frank and I actually mostly Frank run a GitHub repo. You can see on the example here we have some examples of the container design decisions and some of the prescriptive guidance on this particular URL. I hope you like the talk, and let us know if you need any more details and help you build an ADR for your particular scenario. We are there to help you out. Thank you very much.